welcome to Maths Live. We've already got Sam in Nottingham, Harry, Naomi's taking part, Seb's taking part. I'll have a look at some more of the shout outs in a second. So, recapping from yesterday's lesson, converting between mixed and improper fractions. First one, we've got an improper fraction I'd like you to convert into a mixed number fraction. And secondly, I've got a mixed fraction and I'd like you to convert it into an improper fraction. Have a go at that. I'll be back soon. Do some more shout outs. Hi Jensen. Hi Sorel in Bedford. Hi Zach and Safa in Cheshire. Hi Tej and Hemel Hempstead. Hi Josh. Hi Amelia. Hi Rio. Oh, got some answers coming in. Hi Ethan. Hi Ariana. Hi Kieran. Oh, lots today. Hi Seth in Kettering. Right, already got answers coming in. So I'll give you a few more seconds. Hi Tom in Broughton. Hi Namira. Hi Shalina. Oh, lots of new people today, that's nice. That's nice. So today we're going to be adding and subtracting fractions after we've done this challenge. Which is quite a good topic because it does start off quite easy and then it does get tricky, but we always like a challenge in Maths Live. So, got my board rubber. Right, let's recap from yesterday then. So when we're converting from an improper fraction into a mixed number fraction, so if I rewrite it up here, so I'm going to get rid of this. So the denominator has to stay the same, so you know it's going to be over 5. And remember, 5 out of 5, when the top number and the bottom number are the same in the fraction, it means it's one whole. So we're looking for how many groups of 5 are in 32. So what you do is 32 divided by 5. So we know that 6 5s are 30, so there's 6 wholes, and then there's, because we want 30, we want 32, there's 2 remainders. And you can check this by doing the inverse. So you'll see it when we do it down here, but if I do 6 times 5, which is 30, and plus my 2 is 32, 32 over 5. Okay. And for number 2, it's 3 4/7, and we know it has to be over 7. So, quickest way to do it, we know that the 3 here actually means 7 over 7, 7 over 7, 7 over 7. But you can't, say this number is 21, you can't do that 21 times. So don't worry about doing this. The easiest way to do it is multiply the whole number by the denominator. So 3 7s are 21, add the 4 to 21 makes 25, and there's your improper fraction. Okay? Good. Right. Adding and subtracting fractions. So we'll come to the challenge questions in a bit. Don't worry if you don't know what I mean by the challenge questions. I'll give you a chance to do them anyway. Challenge questions go up on the page at 10 o'clock every morning. You can do them at 10 o'clock, you can do them at 12 o'clock, you can do them 5 minutes before the lesson starts. It's up to you. If you don't get a chance to do them, don't worry, we'll have a look at them here. Right, adding and subtracting fractions. All I'll say really, really quickly, it's fine if the denominators are the same. So for example, if I've got 1/11 and then I need to add 3/11, that is just 4/11. So the denominators stay the same, so 11, 11, so it just stays 11, and then you add the numerators. You're allowed to add the numerators straight like that because you don't have to change the denominator. I'll show you an example of why. I'll show you, try and show you a clearer version. So if you have 2 over 6 and you have 1 over 6, now picture it like I always say, like a pizza. So I'm going to split my pizza into groups of 6. So I've got 2 over 6 shaded. Okay. And then I add another 1 over the 6, so 1 out of the 6, and that equals 3 out of 6. You can see 1, 2, 3 out of the total of 6. So it doesn't matter what the denominator is, that is the rule each time. So there you go. If the denominators are the same, it's nice and easy. Same with subtraction. So if you're doing, say, 5 sevenths, take away 2 sevenths, your denominator stays the same because it's already at 7, and 5 take away 2 is 3. Okay? But it's not always as easy as that. No, because we know in maths that fractions don't always have the same denominators when they're working with each other. So for example, we might have 4/5, we might add 1/3. Okay? A scenario might be, again, someone might have, say, there's 2 pizzas. One pizza is split into 5ths, so 1, 2, 3, 4, 5. Another pizza might be split into 3rds. Okay? And you might eat 4/5 in this pizza and 1/3 of that pizza, and you've got to think of a way of saying it. You can't say you've eaten 4/5 and 1/3 of pizzas. There's a way of doing it as just one fraction. So how could you say as one fraction how much of those pizzas that you've eaten? I will show you. Now then, this requires our knowledge from Monday. Those of you who were with me on Monday will remember that we did equivalent fractions. Equivalent means you have to change the fractions so that they are the same. And we have to do this here. We can't add fractions without the same denominators. Okay, they have to have a relationship. So what we do is we make the denominators so that they are the same. The quickest way to do that is multiply the numerators. So 5 times 3 is 15. So now we've got common denominators, but you need to balance them. You can't just put 4 and 1 because that doesn't work. Okay, it won't have been the same fraction coming down. So what did you do to 5 to make it into 15? You times it by 3. Do the same to the top. 4 times 3 is 12. Then what did you do to 3 to make it into 15? You times it by 5. Do the same to the top. 1 times 5 is 5. Now you can do it. Okay, so now the question is, what is 12 15ths plus 5 15ths? 12 plus 5, so that is 17 15ths. Okay, so you've got 12, 13, 14, 15, 16, 17. Some people asked about simplifying. I am going to mention simplifying today, but I'm not going to model it too much. I'll explain why in a bit. We can't simplify this fraction, okay, because there's no common factors of 15 and 17 and 15. The only thing we could do is put it into a mixed number fraction, but that isn't always as important. It's only when you're making the actual fraction itself smaller. Here's another example. 7/8, I'm going to subtract 1 over 6. Now, same problem here. We're doing a subtraction sum, but our denominators are not the same. We have to change them so they are the same, so we're doing a balanced calculation. Quickest way to do it, 6/8 are 48. Okay, what did you do to 8 to make 48? Times it by 6. 7 6s are 42. So I've done the same to the top as I've done to the bottom. Then we're taking away. What did you do to 6 to make it into 48? You times it by 8. So 1 times 8 is 8. Okay? So we've now got our sum that we can do. 42, take away 8, so 42, 41, 40, 39, 38, 37, 36, 35, 34. 34 over 48. Now, this is where we could simplify. So, you have done the correct sum. you've done the correct sum and you've used the correct method, and in a way you've got the correct answer. But a lot of the time it'll say give your answer in its simplest form. And when you're in year 6 and in secondary school, it'll always expect you to give it in its simplest form. It won't tell you. So 34 over 48, how can we simplify that? You might think, right, you can take a little bit of time to think of common factors. The quickest thing I would do straight away is I notice they're both even numbers. So straight away I'm going to divide them by 2. Okay, so half of 34 is 16 and half of 48 is 24. Now, can I spot any common factors? So 16, 5 plus 2, 6, it's 4. They're both in the 4 times table. So 4 4s are 16, 5 4s are 20, 6 4s are 24. Getting closer. You see how many times you've got to do it? So divide that by 2, that is 2. Divide that by 2. So the original question, which was, what was the original question? It was 7 eighths divided, take away 1/6 is actually 2/3. That is the answer. If you simplify as much as possible. That's a lot of calculating. Don't worry too much about this. Okay, this is the method we really want to remember today, is actually how to use our equivalent fractions to get to that answer. If you've understood how to get here, brilliant. If you've understood how to get here, whoa, your brain is on fire. Okay, like I say, I'm not going to overly focus on simplifying fractions because I've already done a lesson on that. And you can go back and have a look at it. Right. Your turn now. 3 challenge questions. We have 1, 2, 3. First 2, nice and easy. Last one, bit more of a challenge. So it was 2 sevenths plus 3 sevenths, 8 ninths, take away 2 ninths, and the last one, 4 tenths, take away 2 eighths. Give those a go. Did I make a mistake? 34. Oh! It is 17. I've not done one in ages, have I? Sorry, my brain is not working. So yes, half of 34 is 17. Well done, team. Well done, guys. you literally have all told me it's 17. Good. Oh, well done for getting them right. Brilliant. Oh, got the answers coming in. Okay, give me a few more seconds. I love that everyone was sort of saying to me, she's wrong. It's 17. No, it's 7. Yeah, you said it was 17. I said. I do. Everyone makes mistakes, especially me. So 2 over 7 plus 3 over 7. 2, 3, 4, 5? It's 5, isn't it? It's 5. 5 over 7. 8 take away 2. So 6 over 9. These two are nice and easy because our denominators are already the same. So absolutely no problem there. It's number 3 where we've got to do some changing. Okay, because we haven't got common denominators. So I'm going to go up this time, make it easier. So we times by 10 by 8, so it's 80. So what did we do to 10 to make it into 80? We times it by 8. So 4 8s are, so 4 8s are 32. I'm really like double checking what I'm doing now. So what did we do to 8 to make it into 80? We times by 10. So we do that, so that's 20. So 32, take away 20 is 12 over 80. Okay? So a lot of you got that answer, and that's really, really good, but I saw some of you go ahead and do some simplifying, which was amazing. So again, 12 over 80, can I simplify? I know I can simplify it because they're both even numbers. Just think, right, what can I do? 12, what number is in both? What are there multiples? 4. So 4 times 3 is 12. And then 4, 10 4s are 40. So 10 4s are 40, it must be 20? Yeah? Because I don't know if you know that. So if you do 10 times 4 is 40, or 2 times 4 is 8. So if 2 times 4 is 8, if you add a 0 there, that makes 80. Okay? Can we simplify that anymore? So think of your 3 times table. So 3, 6, 9, 12, 50, 80, 21. No. So that is the smallest answer that you can get. Well done. Very well done. Some of you told me this and then went straight to this. Some of you just told me this. Like I say, I'm not picking up on the simplifying too much, but I am just reminding you that it's there. Right, seeing as you lot are so good today, you are always good, but you've already been super good. So you also challenge questions, 4 challenge questions today. So the first one is 3 over 8, subtract 1 over 9. And question 2 is 2/3, add 4/6. Off you go. Full marks. Brilliant. Oh, so that's really good because some of you did some simplifying. You didn't get right to the end, but you tried it, and that's great. That's really, really good. Yeah, well, Lachlan, Harneck, well done. Yeah, well done, Kieran. Ooh, you're all beaving away. It's gone very quiet. So I'm going to wait till I see an answer come in for one of them and then I'll go up on the board. Oh, we've got a question mark. Hi, Jensen in Malaysia. Right, we've got an answer coming in for number 1. I'm just going to move number 2 down a little bit so I've got some space. So I want some space up here to do some working. Let's have a look. Yeah. Oh, at the start I was not that good, but now I said, oh, that's good, Steph. Yeah, if you're not that good at the beginning, but then you're even just a little bit better, that's fine. Yeah, you don't have to be an expert at it by the end of the lesson. Okay. What's good about these videos is that you watch, take part, and in a few weeks you might have something set by school, or you find something that you're given a question, and think, oh, I did that with Steph. You might go back and watch the video, and it all clicks again. So that's absolutely fine. Right. We need to make it in common. So 9 8 is 72. Always remember, if you're adding and subtracting, put it in there so you don't forget. It's like when you're doing biggest to smallest with ordering, don't forget which way you're doing it, okay? Because that's the easiest thing to get confused on. You might just go, oh, I'm adding. You're not, you're subtracting. So what did you do to 8 to make 72? Times it by 9. Do the same to the top. 1 9 is 9, 2 9s are 18, 3 9s are 27. What did you do to 9 to make it into 72? Times it by 8, 9 8 is 72. Do the same to the top. So that's 8. So 27, take away 8, again it's going to be over 72. So 27, 26, 25, 24, 23, 22, 21, 20, 19. So 19 over 72. So you might think, right, can I simplify that? So 3s, 4s, no 5s, no 6. There should be a reason. Why do you think it is? Can anyone tell me a reason why it jumps out at you that you can't do this calculation? Let me just see. I'm just going to see if anyone notices. Can anyone give me a quick explanation of why you cannot simplify? I'm just going to see if it pops up. Hold it up. Anyone know a reason that jumps out in this fraction why it's not? So 1's an odd number, good guess, but say for in the 3 times table, some of them are odd numbers, so you can still get factors that go in. So for example, if it was 3 over 15, you know that both of them are in 3 times table. Yes! Who said that? Someone, I saw it. Heidi Perkins, well done. Seb, it's a prime number, well done. Yes, 19 is a prime number, so it's not divisible into anything, so you know immediately you can't simplify that. Well done. So, this question. 2 over 3, 4 over 6. So, 3 6s are 18. I'm just going to put it above there. 6 3s are 18. What did you do to 3 to make it into 18? You times it by 6. So 2 times 6 is 12. What did you do to 6 to make it into 18? Times it by 3. So 4 3s are 12. Oh, that's funny, isn't it? I didn't realise I'd done that. So it'll be 24 over 18. I keep doubting myself now that I'm doing it wrong. Right, 24 and 18, we know immediately that we can simplify that. Again, you might jump straight in and try and find the biggest common factor. I always just go and think, right, I'm going to, if it's an odd number, I'll divide by 2 straight away. So 24 over 18, if I divide that by 2, that'll be 12 and 9. Can I simplify that again? Can you think of another common factor of 12 and 9? 3. So 4 3s are 12, and then 3 3s are 9, so 4 over 3. You could also write it as 1 and 1/3. Let me see. Okay, I'm just going to have to scroll all the way back up. 24 18, yes, well done. Brilliant. Now, I've got a range of answers for this one. So some people put 18, some people got to 12 over 9, some people got 4 over 3, so it's okay. Like I say, I'm looking for the method today, not the simplifying. Okay? Because that's simplifying something you can practice in your own time. Right, 2 more questions, guys. You're doing so well today. So, question 3 is 9 over 12, and we're going to add 1 over 5. And question 4, last question, is 9 over 10, subtract 4 over 6. Give those a go. Well done, yeah. Loads of people have said prime number. Yeah, it's not always, so remember, it doesn't have to be an even number to make it smaller. So if it's, because lots of numbers in the 3 times table, for example, can be divisible into it. They have to have common factors. But 19 immediately jumped out because it's a prime number, so that means it can't be in any other times tables. Oh gosh, we're already doing this question. Amazing. I got some answers coming in. Can any of them be simplified just as a challenge? So for example, Kieran with number 1, can you simplify that? A few of you have got that first answer. I don't want to read it out and give it away, but can you, and there's a few, yeah. Can both of them be simplified possibly? Wow, we've got a few different answers now. Give you a few more seconds. Right, let's have a go. So, 12 times 5, 1 12 is 12, 2 12 is 24, 3 12 is 36, 4 12 is 48, 5 12s are 60. What did you do to 12 to make it into 60? Times it by 5, do the same to the 9. 1 9 is 9, 2 9s are 18, 3 9s 27, 4 9s 36, 5 9s 45. What did you do to 5 to make it in 60? Times it by 12. Do the same to the top. That is 12. Whoops, there goes my lid. So add these together. That is 57 over 60. Now, can we simplify 57 over 60? 57, I think it's in the 3 times table, if I recall. So I'm just going to do a bit of playing, a bit of division. So there's 1 and then there's 2 left over. 9 3s are 27. Ah, it is in the 3 times table. So if I divide it, I've not really got much space here, have I? I'll move it up here. So if I divide it by 3, that is 19 over 20. So that's in its simplest form. Tricky one, that one. I seem to remember the pattern of 15 over 7 and then with 3. Again, we know we can't simplify this further because 19 is a prime number and they're right next to each other. Okay? Good. And I saw a few of you hadn't spotted that, but it is a tricky one. Well done for getting the right answer. Right. Next one. 9 over 10, take away 4 over 6. Let's go up. So our common denominator is 60. And we are subtracting. So what did you do to 10 to make it into 60? Times it by 6. So 6 9s are 54. And then what did you do to 6 to make it into 60? You times it by 10. So 10 times 4 is 40. Do your subtraction. So 54, take away 40 is 14 over 60. Can we simplify that anymore? Can we simplify 14 over 60 anymore? We can. We know we can because they're both even numbers. That jumps out at you. So if I divide the top and the bottom by 2, 14 divided by 2 is 7. 60 divided by 2 is 30. Can I simplify that any more? 7 into 30 doesn't go. No, great. Doesn't go any further. So I'll simplify. So 54 over 60, take away 40 over 60 in its simplest form is 7 over 30. Let me just see if anyone got that last bit. Let's have a look. Oh wow! Well done. Kind of amazing. Well done, guys. So not only have you been adding, subtracting fractions with common denominators, you've been using the equivalent fraction skills from Monday to add and subtract fractions that are not equivalent. Hard work that. Well done. I'm going to put a challenge question up linked to this in a second. Tomorrow we're going to be multiplying fractions. Multiplying fractions from a whole number, so you might do 3/4 times by 6, or you might multiply two fractions, so you might do 3/4 times 1/6. It's a lot of fun multiplying fractions. I really enjoy it, so hope you can join in. Well done today. See you tomorrow. Bye bye.